find it about two things about PCA, but actually I am
Mm,
trying to understand that.
uh-huh.
So I want some debate or some explanation from you guys. So please participate. Thank you.
Okay, yeah. I just started to record. I just started to record our the WebEx meeting on November uh, 16th. 16th. Yeah. Okay. Yeah, we just started to talk about what you have done since after the midterm examination. And Giri, yeah, yeah, what you have done so far after the midterm examination.
I have just watched through all the video lectures till week 11 and completed all the open problems.
Mm-hmm.
And yesterday I saw the comment of Daniel regarding that replacing one code with another smaller part so that it will run the code more faster.
Mm-hmm.
And then yesterday I was going to watch week 12 video, but that main lecture, the screen was frozen. So today I watched ANN and back propagation.
Mm-hmm. Mm-hmm.
And
That
I
okay.
will,
We went through that. Oh, good.
yes,
Mm-hmm.
and I will be uploading that open problem till midnight today.
Mm-hmm. Mm-hmm.
And that's it.
Okay, but I wanted to see more of your activities in Q&A. I want you to solve the problems and add your comment on others' solutions and to chat more until you really understand yeah, how those concepts are well related. Basically, how you use the knowledges that you have learned from part 1, 2, 3, 4 in part 5. So, yeah. So when we talk about the principal component analysis, yeah, you should understand why we have learned the first 4 chapters and how those mathematical concepts are used to go through the part 5, PCA and artificial neural network. Okay, Kim Dani, yeah, tell me about what your progress since the midterm examination.
Basically also did the same, watched all the lectures. Actually, the combinatorics part was pretty helpful
Mm-hmm.
because I'm also taking other math classes, so that was pretty helpful for me. And
Uh-huh.
also, but the thing is the gradient descent method, right? So
Mm-hmm.
it apparently doesn't work for everything. Like,
But yeah,
yeah,
yeah, definitely every math problem has conditions to use the theory to be adapted. So yeah, sure. There is a condition to start to the algorithm uh, in order to get the solution that we wanted to get. Sure. Yeah. So what? So but for the continuous functions which has a relative extrema, then if we start near that extreme point, then gradient descent method uh,
we'll find it. Yeah.
will find the solution. So yeah, the only thing is yeah, we know where we start, where
Yeah,
we
because
set.
if we choose incorrectly, it can go to infinity, like,
Yeah.
and won't find it.
Mhm. So we need to have a big picture of those problems, and we should have some uh, kind of some like a big the log shape of the functions or graphs, or uh, when we have a multi-variable functions, then we should have some ideas to choose a right initial point to start. So yes, and with those understanding, yeah, we can have a reasonable algorithm that works without much the difficulty for the general problems. So yeah, eventually when you read the code, then you will understand those what kind of how those the trial and errors and the mathematical understanding were implemented to the algorithm that we are using. Yeah, and yeah, gradient descent method. You now you can use it. Yeah, and if you don't get the solution, then the what you want, then yeah, you will understand. There are some where you go back to check. So you can have the answer that you wanted to have. And then after that.
After that, so we also did we went to the chapter 3, right? So we also already moved to the chapter 3, and again, chapter 3 was a calculus part, right? So there was some
Yes.
integration, also differentiation and limits. And also I pretty much enjoyed the probability section. And it was interesting to read more about the Monty Hall problem.
Monty Hall problem. So, and you think you have solved the most of the open problems so far up to the first 4 chapters?
Yes, I think I solved all the problems up to the chapter 3, problem 3. Yeah.
Okay, good. So now you understand the singular decomposition and gradient descent method and the basic statistics, okay, including the covariance matrices. And with those, you must start with the principal component analysis. So how was it?
I haven't started it yet, but I'm planning to start today. Yeah, week 12, right?
I see. Yeah. Giri pointed out I uploaded the 3 lectures on principal component analysis, but the second lecture has all the lectures in there, but the screen was stopped at one point. So I will fix that problems. I will, if I don't do it, if I cannot find the right the movie clip, then I will lecture once again to make a right one so you can go through it. But basically, I have delivered the content in our textbook. So, and also you have my web page and lecture note that has all the code and explanations in it. So yeah, you found that. So now you can go through. Those textbook and the lecture notes and the lab that I made for you. Then you will understand it. So when you find any difficulty, then just you ask question to understand what is written in the book. So anyway, before the end of this week, I will upload it to the another new lecture of mine on PCA in our campus. Okay, and Giri started the artificial neural network already, and uh, and have had some questions. Okay, talk more about what you have found in the lectures for 13th week. We are very close to the end already. Yes.
This was really interesting, sir, because this ANN artificial neural network worked in the same way how our nerve cells work. Like at first, I was quite confused with this weight part because it was written that each input signal has its own weight. But now that we have cleared it, it has been easy for me to understand. It has been detailedly explained how this artificial network works by using linear combination and activation function.
Yes.
And then how the formula and how we use the formula using transverse matrix so that it can be easily identified. And then for back propagation, it was also it is like similarly as ANN, but in this we have to identify error and reduce the error until it is fully reduced. And just it is just all about this computation, mathematical computation and understanding, sir.
Good. Yeah, Giri, you are a freshman now. Is that right?
Yes, sir.
A freshman. Yeah. For the freshman, yeah, the last chapter of our course must be very new to you. Yeah, and it's actually the most of graduate students are learning those the back propagation algorithms and artificial neural networks and machine learning. So you don't have to have lots of pressure to understand everything of those here there. I expect our students to understand the terminologies in the last chapter, and I expect you to understand the back propagation algorithm properly.
Okay, sir.
All the others are consequence of those, and and also at the end of this in the lectures on 14th week, I introduced the application of the artificial neural network, which was used on the post office. And for many years, when we wrote the letter, then we write the address and the names and zip code. Okay? And for many years, the post office spent a lot of money and time and manpower to sort all those collected the letters, envelopes. Artificial neural network actually was applied on those to sort all kind of those the mails and envelopes by recognizing the zip code. So all those has been done with those algorithms that using these those back propagation the algorithm and code. So and it is those are called by what the handwritten letter recognition or artificial neural network or machine learning, and all those ideas were used, and the many names was given on those processes as the technology has been improved. all those technology was applied to improve the those the classification process, and that really have made the big changes. It really saved the time and money and manpower. So nowadays they don't have any person who really collect the envelopes here and there. So 100,000 and tens, maybe a million jobs are lost with those technologies. The recognition of handwritten letters, and those technologies can be used to not only for the letters and numbers, but also it's applied to the voice recognition and pattern recognitions, and go on, including the natural language process, etc. So anyway, all those the background of those artificial neural networks are based on the back propagation algorithm. So yeah, if you try to talk about those back propagation algorithm and the principal component analysis, then you will really understand the mathematics that you have learned from the first 4 chapters. Okay, so I want to see that you guys are really talk about those mathematics which really are used in those essential algorithms that really make work the machine learning and artificial neural network. Okay, Kitty. So just enjoy what you are reading, what you are learning on chapter on chapter 5 on principal component analysis and the artificial neural networks. And if you understand those core ideas, then that will be enough to pass the course with the highest honor. Okay. Okay. Then now we go to share the screen on. Okay. Okay. We go to the Q&A and we see what you have done, and let's talk about the problems and questions that you have raised. We may start with Pastor. Okay, what did you share, Mr. Kim Dasol? Kim Dasol?
Yes.
Yes, what was found?
This is a PCA about the PCA problem, and the question is find the data matrix from my major period and apply PCA algorithm. And
Mm-hmm.
I majored on data science, but I'm
Mm-hmm.
interested in the genome data, the human genome data,
Mm-hmm.
especially of cancer. And it is a TCGA,
Mm-hmm.
a kind of a data portal of genomic data of
Mm-hmm.
cancer patients. So
Uh-huh.
I pre-processed it about the downloaded data from that, and then
Mm-hmm.
I used a PCA function in scikit-learn. Then I
Uh-huh.
found uh, first components have 82% the
Mm-hmm.
explain the variance ratio. But I'm curious why that is too high because
Too high.
yeah, it is too high because
Mm-hmm.
genomic data is uh, very
That's right.
large,
The
and
millions of, yeah.
yeah, it should be less than 80.
Uh-huh.
But it is too high. So
Possibility, yes. Mm-hmm.
that
Mm-hmm.
is my question, and if you have an answer, please comment that.
Mm-hmm. Okay, yeah, let's talk about what it happened on this
Uh, and
analysis.
there is one hypothesis from the friend of
Mm-hmm.
mine. The thesis is because there is a basic baseline of a genome because there is some base genomes. Most of the genome are similar between the persons because we are all humans. We are all made by the cells. So because of that, most of the cells are similar. So most of the data are similar. So the first component is that high. That is one thesis. So with that thesis, I should pre-process the data matrix rather than 60, 60, 60K. I should make uh I should make principal genes. I should make the gene set uh more smaller. So I should
Mm-hmm.
pick up some hundred genomes. Then
Mm-hmm.
I made a data matrix with that. That is the one way to solve this problem.
Mm-hmm.
Yeah,
Okay.
this is
Uh,
the things what I
uh,
am doing.
so, yeah, I understand. But the genomic data must be really big. If
Yeah,
you, yes. So what kind of computing power that you are using now?
I have pretty much good computer powers, but
Computing power, yeah.
yeah, computing powers because I have my desktop pretty good,
Desktop.
and
Uh-huh.
there is a server from my school, so
Uh-huh.
I can handle with that with
Uh-huh.
big data, maybe
Mm.
maybe some gigabyte units, but the real problem is uh,
Uh-huh.
that is too big, so I should select and I should
That's right.
filter that
Mm.
data. That is the
Mhm.
problem. Actually, the computing power is not that important
So,
thing.
so,
Yeah,
so I recommend you to use a reasonable size of data to
yeah,
analyze it with your computing power that you can utilize it. Yeah.
yeah, yeah,
If data is too big and your computing power is too small, then you wouldn't get any good results, good analysis out of it. So this is the introductory course. Yeah, you may just start with about couple of hundred or maximum size thousand uh, by thousand matrix to be analyzed. Then you
yeah,
will have a reasonable analysis. If you have
yeah,
a million by million matrix with your laptop notebook, then then yeah, you won't get anything that is meaningful, right, to you. Anyway, the Giri and Kim Daniel, you may add your comment and questions or other suggestions yeah, related to this problem. Okay, and yeah, we just started it and. Yeah, explain how the does it. So what you found? Yeah, explain. Yeah, how? Did you understand how the singularity composition was used in PCA? Do you understand it now, or any more? Any
Yeah,
questions on it? On these questions and this problem?
I'm good. I was confused about that, but
Uh-huh.
I found that the SVD singular value decomposition is
Uh-huh.
uh principle in PCA,
Uh-huh.
and then that that makes sense. So
Makes sense. Mm-hmm.
yeah, because I understand the single value decomposition, and then
Mm-hmm.
it is important things in PCA, and
Mm-hmm.
PCA actually I'm so confused about the PCA, but it is after the single value decomposition is working in the PCA. When
Uh-huh.
I understand then the PCA is so clear to me.
I see. Good, good. Yeah.
Yeah,
And also, do you understand the length reduction? How the length reduction can be done with the truncated singular
yeah. Yeah.
decomposition? Mhm.
That is
So,
that is
mhm,
the changing the lower component
mhm,
and lower
mhm.
elements in the
Uh-huh.
sigma
Mm-hmm.
to
Mm-hmm.
change it into zero. Then
Mm-hmm.
and the corresponding elements before the left side and right side is
Mm-hmm.
remove the detection.
Yes.
So
Good. Yeah.
yeah,
Yeah. It's
that is
worth to learn mathematics to understand the cliches. So the time that we spent was must be valuable, yeah, to really understand the principal component analysis. Okay, yeah, Daniel, would you explain how the singular value decomposition was used in PCA?
Oh, I didn't start PCA yet, so I'm
You haven't
not really
started.
sure.
I see. What about Kiri? Okay, can you explain how SVD was used in PCA?
Not started it.
I started. Okay. Yeah. Okay. You are a you are a freshman. So yeah. Yeah. Don't. Yeah. You can go slow. Yeah. Still have time. Okay. And yeah. We had pointed out, and we will fix it. And this was the summary by Kim Dani. Yeah. Okay. Tell me about uh, your solutions on probability and statistics. Yeah, on week
Okay, so
11.
yeah. So the first thing that we will introduce to is the expectation, or in some books it's called a mean value. Okay, basically, sometimes it is denoted as EX and then a number in the brackets, sometimes as E or a grease mu.
Mm.
So basically, it's a sum of your X multiplied by a probability of uh, the probability
Yes.
of this event, right? So here I give an example of a dice roll. Um, here we can see I put 1/6 because a probability of a number on the dice is always 1/6. Okay, and then we sum it up. So 1 times 1/6, 2 times 1/6, and so on. And we get a final expectation value to 3.5. However, like we know that dice, we cannot roll a 3.5 number. What it means is that if you roll a large amount of times, if you roll a dice a large amount of times, and sum these results and average them, you will get a number close to 3.5.
Yeah, that's right.
Then we also get to variance. It's also denoted differently in different books, but the point is that variance basically shows you the spread, but considering the average value.
Yeah.
And standard deviation is just the square root of variance. However, some people say that we can use variance to compare. Sometimes people say that it is more convenient to use standard deviation because standard deviation is smaller because of square root. From what I found is that in most cases, standard deviation is preferable to use. However, sometimes, yeah, variance can be better.
Yes.
So some properties and and formulas for continuous functions. Also,
Yes.
here we can find here we can see a integral, right? So this reminded me actually of a Riemann sum because yeah, Riemann sum also replaces the sum with the integral. And also standardized a random variable, right? That reminded me of a vector normalization because after vector normalization, it is easier to compare different, as we in vector comparison, we saw that by normalizing vectors, it is easier to compare different types of data.
Yes.
So the same goes for the standardized random variables. Also, we can compare, like for example, if we have a data in meters and a data in feet, by standardizing them, we can easily compare them without without really caring about different units. We also introduced to a new probability distribution, which is a joint probability distribution, which can basically show a relation between multiple different variables. Like
Yes,
before, we
sir.
only had one variable, but now we can have like any amount of variables. And the covariance matrix basically shows this relation, okay, in the distribution between data. Also, on Wikipedia, there was a very convenient visualization of covariance matrix. Yeah, I think a very convenient method.
Good. Yeah. We really went very quickly up to these covariance matrices, and in a very short time. But do you think do you think you are now confident to build up a covariance matrix from your data, Daniel?
I think with code, yes, but still we didn't
You
really go
understand
very
covariance
deep.
matrix?
Yeah, I have a understanding, surface understanding, but not really that deep. But I think I can
Yeah.
with code, yeah.
Yeah. Actually, in the students who study the statistics for several years or more, and in many courses, they spend pretty much of time to understand up to this point. But you really went very quickly to reach the this point to understand to be able to generate and construct the covariance matrix, because this is the matrix that we're gonna start to use all of our mathematical knowledge that we have learned in this course, and we're gonna use the singularity decomposition on this matrix to do all the PCAs, etc. So you if you can do singularity decomposition and you can do the gradient descent method, and you can find this covariance matrix from the data, then you are well ready for the principal component analysis and the artificial neural network. So that's good. Yeah. What about problem number 2. What did you do?
So problem number 2 asked us to find a probability density function and then find its expectation, variance, and standard deviation. So yeah. I used the formulas that you showed in the video. Basically got easily got what I needed to find. In problem 3, yeah.
Yeah. So you can you can find the expectation and variance and standard deviation for most of the probability density function that is given to you.
Yeah.
Okay. Good. And what about the next one?
In the third problem, we needed to find an initial matrix, any initial matrix. I decided to randomly generate it and so find its covariance matrix. So here I used a NumPy for matrix generation. And yeah, other than that, it has the same code that you also showed in the video.
Okay, very good. Yeah. In chapter 5, the principal component analysis, yeah, you will learn how the data matrix are made, then how that matrix is related with this covariance matrix. You don't really have to find all the variances and covariances. Yeah, you will see the very interesting relationship with this variance and covariance with the matrix product. So anyway, yeah, the knowledge that you are learning here, it will be very valuable to start the next chapter. Okay, Giri, yeah. So Giri, yeah, what's yours? Where is yours? This is Giri's. Yes. What was yours?
I just found this data randomly from internet and used this to find this covariance matrix using the code you had given us.
Okay. From the data, yeah, you form the data matrix.
Yes.
Then we found the covariance matrix. Very good, very clear. And this is the kind of very standard, excellent problems and solution for the level of freshman.
Thank you, sir.
Yeah, you did very well. Yeah, you start. Should start from here, and then you can expand the horizon, the size of data and the level of the quality of the data. Then, yeah, you will really improve yourself. Then reach right to the data of genome of the person that Mr. Kim Daso have treated. You can really deal with the big data that with the reasonable computing power that is also cost a lot of money too. Yeah. When you use the big data, you should consider how much money that you have to spend to analyze those big data. And Mr. Dasol Kim, have you paid the money to analyze the big data? Have you paid any money to analyze the big data before, so far?
No.
Yeah.
What you mean paid? I paid the money for that, or I own the money for that.
No, I
What do
mean
you
pay. Yeah. If we really treat the real big data, then most of the computer do not handle it properly. So we usually use a supercomputer. Then
yeah.
you have to pay the money to use the computing power and time.
Yeah, I know about that. And I have an option to use on Amazon the Amazon Web Service, maybe Amazon
Uh-huh.
Web Clouding Computer Service. That
Uh-huh.
is one option, but you know the Google Colab
Uh-huh.
is quite good. It is
Uh-huh.
they they are make the computing power at
Mm-hmm.
free
Mm-hmm.
in these days. Maybe it will be changed some years later, but
Uh-huh.
now I use Colab
I see, I
Colab
see.
mostly. Yeah,
That's right. Yeah, these days, yeah, you,
Google
at
is
least
good.
you can use Google Colab. Yes, that's right. Yeah,
Google is
before,
best.
yeah, before the the computing time and the money was a big issue. Yeah, yeah. Sometimes we got a large amount of bill after after an analysis of large data. Usually, the graduate students are using all the money uh, of the fund for useless computation because of the long code lines in his draft. Anyway, that Giri did very well. Yes. So what you have learned, Giri, what you have learned from here, from this example, the solution. What kind of confidence that you got from Giri?
So the like I can generate covariance matrix using this code, but
Uh-huh.
I don't have enough knowledge to generate it without any code.
Mm-hmm.
So this probability and statistics is my weakest part.
Mm-hmm.
So I really need to work hard. You need to understand it properly.
That's okay. Yeah, you are doing very well. Yeah. Yeah, at least, yeah, you can start. You have really experienced the standard example of to generate the covariance matrix from reasonable data. And now you can uh, expand your knowledge to more to bigger and the data of your major. What is your major? What is going to be your
Software,
major? Yeah,
software.
software. Okay. So what was your project idea?
So I was thinking of creating one image recognition device for blind people.
Mm-hmm.
So that was my project idea, but let's see. I have
Uh-huh.
4 years ahead of myself. So in that
Mm.
time, I might change my major because I'm interested in data science also,
Uh-huh.
in big data. So I'm for this first year, I'm trying to explore myself to find to just fix in which field I want to pursue my career.
I see. I see. Yeah. Okay. If you find the good data to what you like to analyze, then you may you may modify this code to start with. That that will help you. Yeah. That you may now you may start your project with this data and the covariance matrix. Then you can use all the mathematics that you have learned to analyze uh, those data. That's good. And yeah, you've done yeah the example, the problem, open problem 2 to find the expected value and variance and covariance and standard deviations. Good. And other students didn't add any comment. That's what you are missing. You have to add your comment on others' solutions. So you should have something to fill out your final PBL report. Giri summarized it very well, and there's no one who added their comment on his summary. I want, if one student to summarize a week of lectures, then other student to add or correct or criticize or add questions on those to expand it to understand as covered, not like this. And Kim Daniel, for the next 2-3 weeks of this semester, if you are the first one who summarize contents of each week, then other students should add their summary in addition to the ones who made the summary before him. So like if Giri summarized like this, then I expect the Kim Daniel copy this and add your summary on this. And Kim Dasol copy all of this and add your summary on it. Or ask your question or add your comment, something like that. So you can just 이렇게 work together like a 집단 지성. Yeah. We use our abilities together to understand the big picture, not just staying at the beginning stage. We want to go further and further after we discuss. Anyway, yeah, we finished the about 80% or 70 or 80% of the content that should be covered in this course. And now we have about 3 weeks left. So you go through this PCA and the artificial neural network and the handwritten number recognition with the MNIST data set. And those are the things left. And just I hope you can enjoy those applications that are really a starting point of the machine learning. And all the mathematics that you have learned are selected to be used on these coming lectures of 3 weeks. I think that's enough for today, and let's keep it out. Share, stop sharing this PC. Okay, we have about 5 minutes left, 5-10 minutes, 9 minutes left. So let's talk about the next 3 weeks of lectures and any others. Okay, Giri, any other questions?
No, sir.
So you know what to do from now on.
Yes, I will be participating in Q&A and completing all my lectures and uploading my answers in Q&A and commenting on others' answers.
Add your comment on all others questions or
Yes,
solutions.
sir. Yes, sir. Got it.
Go through and add everything. Okay, and if you want to improve it, then copy the other students' the solution and you can improve it. So you can use it for your final PBL report.
Okay, sir.
Okay.
Yes, sir.
Okay. Then you will have A+. If not, you won. be able to, you will not be able to have A plus at all. No chance. You understand? Don't miss it. Kim Daniel, you know what to do. Yeah, what you gonna do from now on?
Yeah, the same as Mr. Giri said, and also yeah, instead of starting summary from the beginning, just add something that the others didn't mention.
Okay, so you also go through all others the problems and solutions and add your comment and improve it and make the good for problem 1, problem 2, 3. You should have a very good, not only one simple problem, but it should have a very good really problems and solutions and all others as well. Then yeah, you will deserve the A plus. But if I do see that some things are missing, then you will lose your chance for having A plus. Okay?
Yeah,
That's all. What you like to say? We
And
have PCA and artificial neural network and MNIST data.
I understand what people says and what should I do. And I have one question lastly.
Okay.
The project, our final project, is it a presentation or just a report?
Oh, the project is not mandatory. Yeah, it's optional. If you are writing a report or the thesis for your undergraduate project in other course which is related with our class, then you may use the mathematical knowledge that we have learned and mathematical code that we have used in here for your data or for your problems, and then we can share it. Then it will be counted, and yeah. So yeah, what do you have what in your mind? What you have your mind now? Do you have any idea that you can show? You can share?
I
You
just
can apply.
I am going to handle the genomic data, and then I make the project about that. That is in my mind, but if it is not mandatory, then yeah, I just go for the Q&A section and comment there.
Okay. Yeah. Yeah. Then which means that you will be satisfied with the A. Okay.
But
Not A plus.
what about the our final? What is going on our final?
Final
Yeah.
PBL report and final the presentation of your PBL report and your project and others that you can share. You can show.
Okay. Now I got it. I got it.
So in order to be recognized, you have to show your some sort of your the original content
So
from your
I can do my project. I can. Yeah,
yeah, you
and
can sure
that
you can
makes my
share it.
work better.
That's right.
Yeah, I got it. Thank you
If
so
you
much.
can use the mathematics that we have learned in your project.
It should be what I do, whatever I do. The mathematics what we brought are important and it is main. Next thing is
Okay.
good. Yeah, I
To
can share
show it.
that.
So
I will
now
try
the
to share
final
that.
exam is started. Yeah.
Mhm.
Your final exam just started. Yeah, you have learned all the mathematics which is needed for artificial intelligence. Okay. So the PCA and propagation algorithm and the number handwritten number recognition on MNIST data. Those are the applications of the mathematics that you have learned. So now, you do something. You do summarize what what you have learned, and you try to do something on artificial neural network of your interest in your major, and to discuss and add comment on others' work to make something new and interesting. And then I will add my comment, and if those of your work is valuable, then I will give you a chance to talk about what you have done, and the credit will be added on it to give the best thing that I can do for you. Okay? Understand? Or here. And Kim Daso, you are the ones who are very easy, because the Giri and Daniel wrote very well summaries and good problems and solutions. So you can add your comment and improve a little bit of it to add your names, and also it will help the quality of the problems and solutions and summary of those two freshmen. So you, as a senior student with the freshmen in this course, so I expect you can do your proper role to verify your presence and the ability and knowledge. Okay? Okay, I think time's up. So enjoy the last 3 weeks, and I will see you at the campus in 2 days. I'll be back in my office on Thursday. Then you can catch me anytime from now on. Okay, good night, and see you next week. And also, if you wanna see me in WebEx office hour, you can ask me to open this WebEx office for any time, any week from now on. We only have 3-4 weeks left, isn't it? So if you ask, I'm willing to open the office hour in every week. So if you need me and ask me to open the WebEx office hour, then I will be talking with you to help you to finalize your work of this course. Okay. Ask me in Q&A, and
Thank you so
then
much.
I will give the answer, and then we will have more chance to finalize what you're gonna do to reach your goals. Okay, I think that will do it. Okay, bye. Good night. Thank you.
Good. Have a
Bye.
good
Okay.
night.
Yeah. Any of you can summarize some important things that I have mentioned. Then other students will add the comment. Then I will finalize it for today's discussions, so other students can understand it in a short time. Okay. Thank you. Thank you.
Bye.
And it was very
Yeah.
nice to meet you again. Bye bye.
Bye-bye.
Bye. Bye.